Welcome to the Infill Podcast, where we interview the most interesting members of the 3D printing and maker communities, live and with audience participation. And now, here is your host, Jonathan Levy.
All right. Hello, everyone, and welcome. We're going to have a great episode today. I'm excited to get a lot of my multicolor printing questions answered, and a lot of you have expressed interest in open source filament changers. So we're going to get into that. Before we do get into that, I have to thank this video's sponsor, the first sponsor of this video. We now have a pre-roll sponsor, and that is going to be Kiddoodle, which is a kid's 3D printer. Really, really exciting. Myself and my guest both have boys, kids, and I know those of us who love 3D printing just want to share it with young people. The Kiddoodle is designed to be a kid-friendly 3D printer with all kinds of safety features such as an enclosure, disabling heaters, and much, much more. And also, it's a 3D printer that your kid will actually want to use and understand how to use. So I was pretty excited about that. Kiddoodle is going to be in a Kickstarter. I believe it has already started now, and we have a link in the description. So check that out. And thank you, Kiddoodle, for sponsoring this part of the episode. Now let's talk about today's guest. Ivan Trail is a member of the ERCF team, the Enraged Rabbit Carrot Feeder team. I'm not going to say that every time, so ERCF for those of you following along at home. And just like many of us, he got into 3D printing a handful of years ago and has become obsessed. He's been a lifelong builder and engineer. Ivan, welcome to the show.
Good to be here.
So I want to get into all the 3D printing, the ERCF, multicolor printing, but I'd love also just get a bit of your story. I mean, I know you're an engineer, you've been in automotive. Talk to me about that transition to 3D printing and when you got hooked.
So being an engineer, there's a lot of CAD work. And when I was in college later in life, I worked as a student assistant at it's NIAR, and part of being a student assistant there was I got PIA classes that they had. So I learned CAD inside and out while I was in school. And of course, that translates pretty much directly into 3D printing because you can make something on the screen and it looks cool and everything, but actually bringing that into the physical world is, apart from having a $2 million horizontal mill there grinding out titanium, now you can do it in your desktop at home. So that's just, to me, is really cool. So,
Yeah.
and
What was your first 3D
that
print?
was the big draw for me. Uh, Christmas time, my older boys bought me an Ender 3,
Hmm.
and I thought about buying a 3D printer, but was kind of like, on the fence about it. And they got me this thing, and from there on, it was done.
Yeah.
And of course, like I think it's necessary when you have an Ender 3, just modify the heck out of it, right?
Sure.
And so I did a whole bunch of that. And I jumped straight from there into my Vorons, and
Really?
that's really all I've had. Yeah. Of
You said
course,
Voron's.
being an engineer and a mechanic, um, the Vorons where you build it all, yeah, that really spoke to me, I guess you'd say, yeah.
So you said Voron's plural. How many of them have you built at this point?
Right now I have a 2.4 and a Trident.
Okay.
So,
All right. So you're addicted to the hobby, but you're not addicted to accumulating printers as badly as some of us.
not yet.
Not yet. So somewhere along the way, you went down the path of the Enraged Rabbit Carrot Feeder. Today, you're a member of the team, for those who are just joining us. But you joined it in kind of the earlier days before it was as polished, I think, as it is now. Tell me about that and tell me about that journey. And I guess maybe I'll pull up the ERCF so I can kind of show people what it is and what it was. Sorry, go ahead.
So, oh yeah, the ERCF, I don't remember exactly how I got turned on to it, but I bought a kit I, maybe 2 or 3 years ago. So this would have been the old V1.1 kit, and I built it, and I kind of waffled around about putting it on the printer and trying to get it to work. And I tried a couple times, and I was met with a great deal of frustration. And I think that's familiar to anybody who's built an ERCF is frustration. But the old kit was based on rods to hold the whole thing together, and it
Yeah,
was kind of wobbly. And you could make it work, but it took a lot of tuning. So
yeah,
they kind of got put on the shelf for a while. And the next time I decided to try it, they just started talking about the V2,
right.
and they had released they call it the Sturdy Bunny, which transfers from threaded rods to a piece of 2020 uh, extrusion for the main backbone. A couple other the Springy mod, which helped with the servo, and the triple decky, which was the filling. They kind of clamp better, and they were a little bit more free running than the original, and didn't have the washers for gates. Um, so at that point, I kind of got back into it, and then right around that time, they released everything as the V2, the RC1 version, and
Here we go. I got it
that's when
pulled.
I really started in it, and I got my first successful print. I'm sorry.
I've got it pulled up on screen now just because I don't know how much people know about it. Let us know in the chat how much folks know about it. But I guess I should have taken a step back and asked. I mean, the ERCF predates, and many people will know this, predates the Bamboo Lab AMS system. I don't think necessarily it predates the Prusa MMU, but I'd love if you could explain to folks how the system actually works, right? So I think people are familiar at this point with, the 4 filaments going into one head. They may be familiar with how the different AMS systems work, commercial ones. But give us a little overview of just how the ERCF, either version, works and how it actually swaps filaments so that you can have multicolor.
Yeah, sure. The main body of the ERCF has a 5 millimeter shaft that runs through it, and that has a bunch of BMG gears on it in
Mm-hmm.
each gate, they call it. Um, so your main stepper motor, they call it the gear stepper, runs these BMG gears on the 5 millimeter shaft, and it's got a selector cart that goes across and selects which one. So when it's time to pull a filament in, the select cart moves to the right gate. It's got a servo that pushes down on the top hat, they call it, of the gate, which clamps the idler against the BMG drive gear for that gate. Then the
Mm-hmm.
stepper motor moves and pulls the filament in or out. Um,
Right. So it is
and
it
of
is
course,
very
with
similar to the MMU3, and also I guess very similar to the old AMS, the Bamboo Lab AMS, in that it's one motor engaging and driving.
yeah, and there's a motor that runs the selector cart back and forth as well. So it's got two steppers in total.
Right. And then the idea with I guess folks ask in the chat, because this is one of those episodes I always try not to know. This is going to sound crazy, but whenever I interview someone, I try not to know too much about their work because I want to ask beginner questions. It sounds like you did. I built an ERCF V1, got it all hooked up, but then I started down the path of the configuration, that tip tuning, as they say. And I said, no, I'm not going to do it, because I knew that the V2 was coming out. The V2 parts are already printed and they're here somewhere. It's like many kilos of filament, so it's somewhere on a shelf. Let's explore, because as you said, I think common to the experience of the ERCF V1 was frustration. and a lot of time spent tuning. So I guess
Mhm.
help us understand how the ERCF2 has positioned itself to be more approachable and reliable for the same kinds of people who can build a Voron.
I think the jump to light speed kind of change there was Sorted made the Filametrics, which is a tool head filament cutter.
Right.
Um, and I'm not terribly familiar with anything but the ERCF, but I think the AMS uses a filament cutter,
Correct.
and that might have been where inspiration came from. But
Right.
that
The Filametrics
pretty
too.
well eliminated the yeah, the Filametrics, the tip tuning. So instead of trying to form a tip by driving the plastic back and forth, we just cut it off and go on, you know. And that was what got me my first successful MMU print from the ERCF.
Okay.
And
Now, I think the way you and I connected is I was asking a lot of stupid questions, as I'm wont to do, in the Discord channel. And thanks to everyone in the Discord channel who was helping me so patiently. And what I was trying to understand is about waste, right? Because when you're tip tuning, you're pulling that tip back, you're not cutting it off. But then what I figured out, or what people explained to me, is that actually it doesn't create more waste to cut off the tip necessarily. Tell me about that.
well, so it's a lot like anything else with 3D printing takes some tuning. On my Filametrics on the 2.4, I spent a lot of time changing tools, but I backed off the depressor so that when it made the cut, it didn't cut all the way through, and I could see how much filament was left before the melted end. And I got that down to the just the minimum amount I possibly could. And at that point, my purge block got a lot smaller. Um, so really, you can tune that down to where you're not losing much more than just the melt zone of the plastic when you're changing tools.
Okay, so let me make sure I understand. So actually, and I think this is not something that the bamboo printers do, you're tuning, you're actually retracting the filament so that you're not cutting everything that's in the, I don't want to say in the melt zone, because obviously you're cutting everything in the melt zone. You're not cutting everything that's in the heat break. You're pulling it back and figuring out, effectively you're figuring out how much before the tip of the nozzle, the exit point of the nozzle, how much exactly is melted upwards. Like, is it 1 millimeter, 1.5 millimeters, and it therefore is useless anyway, even if you pulled it back.
Hmm.
So you can cut off just the part that's useless. I guess one could say if you push that back in, it could be used to, push the remaining old filament, but you're talking about a gram or less of filament that's become useless
Yeah.
by melting. Okay. So now I'm
Yeah.
understanding.
And the Happy Hair software, which is amazing. It really is. The Mogi UK on Discord, who's created, he's figured out that you can actually use the filament after you cut it, push that little cutoff to plastic melt zone. So it prevents the hot ends from clogging because you got a piece of filament sticking around there, and it all happens really quick. But it retracts the filament, and you can adjust how much, cuts the tip off, then it jams the little tip back down into the melt zone so it doesn't solidify too much, and it's ready to go when the next filament comes in.
So it
And then
actually
all you've got
is
to
the cut
purge
piece
is that
of
little
filament.
amount that's left.
Sorry, we have a delay. It uses the cut piece of
Mm-hmm.
filament to push it back.
Mm-hmm.
Wow. That's crazy. Okay, now I understand there's two versions or two ways to solve this problem. You can cut that tip at the entrance to the printer, which is, up by the buffer, or you can cut it right at the hot end. What are kind of the benefits, or what's the consideration there? Why would you choose one or the other?
Well, for me, the 2.4 with the stealth burner is this big, healthy sized uh, tool head. It's got lots of room to put a blade,
Right,
spring, switches, and such in it. Now, on my Trident, I have the Zoll tool head, and there is a Filmetrics mod for that. But I'll tell you what, that Zoll tool head is very compact. And I had printed all the stuff for it before I knew there was a filament cutter for it. So on this one, I went with what's called the EREC, Enraged Rabbit Encoder Cutter. So this one mounts a servo right on the selector cart of the ERCF, which is up where it selects the filament. So on this one, you do a few cooling moves to kind of solidify the tip of the filament so it doesn't, blob up. But if it's got any strings left on it, which strings tend to be the problem when you try to
right.
jam them back into the hot end, it causes jams. So this one just pulls the strings all out, and up by the filament selector cart, there's a blade that just cuts the end off, and so you get little tiny pieces of filament that fall out on your workbench, and yeah, you have to vacuum them up, but
Yeah.
then you got a new fresh clean cut tip for the next time that filament goes into the hot end.
Now, you said you don't have experience with the bamboo printers, but they typically, I mean, you're looking at 100 to 100. I mean, it depends obviously how many times you're changing color, layer heights, all that stuff, but 100 to 150% of the actual model weight is purge and waste. What's been your experience with the ERCF V2? How efficient have you gotten it in terms of waste?
I've never really measured it. I can say that it, with tuning, you can get a lot better. Um, and that includes, purge volumes from the slicer. Uh, Orca slicer has a big grid. You can tune how much
Right.
it takes, and that gets passed through, and the Happy Hair software can pick that up and use it with. There's a mod called Blobifier
Right.
where it it puts a little tray out and it just blob on there instead of having a purge tower. Um, so it can figure out after you've tuned it how much to purge for each color combination. And you can get that to be very, very fine and minimize how much waste there is. I
Why
think
would
with multi-material, there's always going to be waste. So
Sure. Why would Blobifier be more efficient in terms of waste than a purge tower?
one of the one of the comments I see quite a bit is if you've got a print that has several layers that are just one color and you don't have to change
Mm,
color in those layers, the purge tower, you've still got to print it at each layer because it stacks up and you don't want to, the next time you swap color, you don't want to print in midair on your purge tower.
got it.
And so there's a little base there, um, which the blob fire doesn't have to do.
I would also think part of it is a purge tower has to be a big enough size, width, and length for your most drastic change. Meaning you're printing that width
Yeah.
and length, and the other layers you can, I mean, it'll just do long spaced lines. It adapts on a layer by layer basis, but
Hmm.
that may have something to do with it. I don't like the idea of
Yeah.
another mechanical point of failure, the servo coming out to move the tray and get rid of the blobs. To me, it's introducing even more uh, points of failure.
And more tuning, it's seems like everything has to be tuned. Everything has to be tuned. So
Yeah, I thought the big selling point of the ERCF V2 was that there's a lot less tuning. I thought it was almost to the point where you don't have to tune, but it sounds to me like the tuning is a little bit more optional and it's around savings rather than reliability. Would you say that's correct?
Some general setup, of course, you got to do, but Mogi has gotten the install script and is constantly refining it to make it better. So when you get it installed, the Happy Hair software, you're 90% there. Um, there's going to be some different values based on, what's your hot end, your extruder, and such like that. And once you get through the basic calibration steps of the Happy Hair, it I'd say you're probably 99% there. Um,
Wow. How reliable
yeah.
has the ERCF2 been for, I mean, not just for you, but for users? Would you say it's at the point where, if you can build a Voron, even if you're not keen on software and you're not a slicing expert, like if you can follow instructions, you can get it working? Or is it still really for early adopters and technically savvy people?
I would say it's somewhere in between. There's still a lot of the whole, like with Voron, everything you compile Clipper and you edit your config files, and the happy or the ERCF and Happy Hair combo kind of adds another layer to that,
Right.
but it's much more refined. A lot of the successes that you're going to have are based on print. When you print the parts, print quality has to be absolutely pristine. There's so much small, light tolerance kind of parts that if you don't have the print quality there, it's going to show up later on. Um, that's that's one of the things when I did the G2E Philometrics mix up. Um, the switches on there, you have to have a great quality print because the tolerance on those little armor-on switching is 0.25 millimeter, and it has a total of zero point 0.5 overrun. So your tolerance of where that switch can fit compared to where the filament actuates the ball is somewhere around half a millimeter. And with a 3D printer, it's kind of tough to hold that kind of tolerance. So you really got to be tuned in. Um,
Right.
and the ERCF in general is kind of that way. So if you want to be successful, get really good prints to start with.
Yeah, and I can highly recommend Ellis's tuning guide if you want to get your prints like dialed in to where they're printed forward quality. There's a guide out there called the Ellis Tuning Guide. I did a YouTube short about it, and it just walks you through. It's basically an interactive book. I mean, calling it a guide, I
Mhm.
think, does not do justice to the amount of information that is in there, and it helps you tune everything from retractions to print speeds to a lot of the things that some of the very advanced printers do by themselves, like pressure advanced. But yeah, I mean that's what ultimately got the print quality perfect on my 2.4. Um,
Yeah.
Thailand GTR asks, is it possible to mount the ERCF on a small bed slinger like the Ender 3?
Mhm. Uh, the ERCF is meant to be printer agnostic. And a matter of fact, I think somewhere in the annals of VCRF stuff, there's a mount that is made for mounting on a bed slinger, and it kind of has a like couple knobs in it, so you can adjust the angle of the ERCF. So yeah, there's people that have put it on these uh, CR10s, those kind of bed slingers, and they work pretty good. So,
That's awesome. Now, we were just talking about the Ellis guide. When you're doing all this tuning, one of my concerns with a lot of the Voron modifications is that they're very well documented if you search through Reddit and GitHub, and then Discord, and then maybe Stack Overflow, and then maybe voronmods.org. It's all distributed in a bunch of different places. So I wonder, what's the best way to go about this tuning? Is it something that's documented in the installation guide? Is it, really you need to participate in the Discord community? How does that take place?
Well, on the Happy Hair GitHub, if you go over to the Wiki tab, there is a pretty comprehensive guide there. Mogi did a lot of work. I think there's something like, what did he say? Over 100,000 lines of documentation he wrote up. And at one point I was there helping, trying to get all the wiki going and edit it. If you look in there, some places you'll see a cat gif or something like that. I put those in because I want people to feel comfortable while they're, you
Yeah,
know, because it's a chore when you dive in and here's this wiki that's, you know, extensive. And, so as you go through it step by step, you need a break sometimes. But
sure.
that's where I would start with the tuning and the configuration is that Happy Hair wiki.
Yeah, and I have to take a minute to thank our sponsor, but I'll just say I've never heard in any of my video comments, when I review a printer that comes, like the A1 Mini, comes with a multiplexer system built in, nobody ever goes in the chat and says, I could just build it myself, open source. And I think it's because people understand that, like, it's a lot of work and you can, but it's still at the hobby stage. You better enjoy building and creating and tuning. Otherwise, it's maybe just worth spending a couple $100 more. I mean, these days, like some of Bamboo's multiplexer systems are so affordable, you might even save money if you factor in your time. But really quickly, let me take a moment to thank this video sponsor, which is, there we go, PCBWay. As you guys know, PCBWay does all the things, whether it is 3D printing. I'm trying to pull up their website, but it's not loading for me. Here we go. 3D printing, metal 3D printing, injection molding, sheet metal muted. I wonder how long I've been muted. Okay. I watched a video today where someone had 3D printed metal from PCBWay and it was stronger than the CNC'd version, which is crazy to me. I don't understand how that could possibly be, but they do all the things. They can make sheet metal fabrication, CNC machining. They can do injection molding, SLA, really anything that you possibly want with super high quality. I've been using them for a bunch of my videos recently, and I highly, highly recommend them. So thanks to PCBWay for sponsoring this video. All right. I don't know how long my audio went out. It always goes out when I cut to the video. But PCBWay, totally awesome. And I think we're back. Hey, Nadir. Okay. Talk to me about multi-material, because one of the criticisms of a multiplexer system is it's not as good for multi-material. If I want to do PETG supports with PLA, or I want to print TPU, well, TPU is a non-starter, right, for any kind of multi-material Bowden. But if I want to print an ABS part with, carbon-filled nylon other parts, can I do that with the ERCF? Or it really should be similar filaments?
That's a great question. And I haven't tried it myself yet. What I'm pretty excited about is, say, the more technical prints, um, where you need to have a really good supported surface and something that's just perfect. I've got a roll of HIPS as a support material that I'm looking forward to trying with an ABS print.
Yep.
Um, and HIPS is supposed to be dissolvable in citrus-based solvents. So that, you print it all out and dissolve the supports away. I'm looking forward to trying that. I have also heard that, like PVA filament does really good for ELA and other materials. But I haven't tried it. I'm looking forward to it. I got plenty of hair, so when I when I get to that point, I've got plenty to pull out, I guess.
Totally.
But I don't see any reason it wouldn't work. Um, it just you'd have to tune your purge volumes and such like that. So,
But Happy Hair will handle, I guess actually the slicer handles if I want to heat up the hot end, print a PETG layer, cool it down. All that should be handled in slicer.
yeah.
So it should be doable.
And yeah, and when you set it up in your slicer, there's in the wiki of Happy Hair, there's a guide for your slicer start codes, and it will actually pass all the tool temperatures to Happy Hair,
Okay.
so even Happy Hair knows what's going on.
Yeah. The more I think about this, the more I'm really trying to understand, just kind of the breakdown between a multi-material and a multi-head. And the lines are getting blurred because multi-material systems, multiplexers, are getting better. But also, we have the stealth changer. Multiple tool head machines are getting cheaper and more available. And, if Teaching Tech is able to do it on a Sovol SV06, he's going to have a 5 tool head, basically Voron 2.4, but not Voron 2.4, for less than some of the Voron 2.4 kits. So the lines are getting blurred. I wonder if you have any thoughts on that.
So, I haven't tried them yet, but the tool changer, they look so cool. I mean, watching those things, yeah, it's just amazing, and a lot of that harkens back to when I was a CNC machinist, and you've got this big chain that's got, say, 200 tools in it, and it just automatically switches out and off you go. And
Right.
which one would be better? I don't know. I suppose there's pros and cons for each. Like, say, the ERCF is one unit, you build it, you don't have to build, you know, X number of tool heads.
Mm-hmm.
But with the tool heads, you're not going to lose your purge volume, because it's one filament in that tool head. And
Right.
I, I I haven't seen how fast they are other than a few videos, but I think the tool head changers as they progress, they're going to get quicker, and you'll be from tool to tool in a couple seconds probably.
Right.
And the ERCF, I can get my 2.4 down to, I think I do about 12-second tool change, and
Wow.
that's after working with it quite a bit. So
That's very fast, though. If you compare to, the Bamboo Lab, the old AMS is 2 to 2.5 minutes, depending on how far you have the AMS from the printer and how much you're purging. 2 to 2.5 minutes. The AMS Lite is much faster,
yeah.
much, much faster. But it's still,
So
a minute.
but and if we're including the purge block in that, yeah, it could be a minute or so. Just from retracting the filament from the tool head to putting the new filament in, I can get it down to about 12 seconds. So,
Really
um,
cool.
and that's with as short a bound as I can get. And I've got a bigger motor, and I've jumped up the current, and so I can push the filament 300 to 400 millimeters per second through the Bowden tube. And it took a long time to get there. So,
Yeah, I'm honestly dreading the tuning part because part of my issue is once I do a video on something, I can't justify spending more time on it just for my own pleasure. Like if I've already done the review or I've already done the live stream, it's like I want to play. I mean, in the case of tuning and going through hell, tuning tips and stuff like that, I don't want to do it. But there may be printers that I want to spend the time getting working. It's like I have to do what the audience wants next. So if they want another video in the series, great. I get to play with it more. But if the first video doesn't perform, then it just gets stuff collects dust. but I shouldn't complain because at least I get to play with the printers in the first place. Tell me about your role in the ERCF team. So who does what? It's kind of this distributed army.
Yeah, I got pulled in as a beta tester because I did the G2E Filmetrics mod, and uh, BSX 8299. I have to think about that for a minute. It's a lot of numbers, but he saw the work I did on that, and then got a hold of Kinematic Digit, and who's the guy that designed the Cottontail buffer,
Mm-hmm.
and they invited me to be on the beta team and help out. And of course, Mogi, he's the guy that does the software side, the Happy Hair. Um, and we've got several other contributors, Miriax, uh, and I think he was actually back to the old V1 times. And I'm just a new guy team, but yeah, we all kind of get together and discuss ideas, and somebody's always got something new to print and try out and see how it works. And so it's a lot of fun hanging out with those guys on Discord.
Very cool. Now you mentioned the buffer. I'm glad because that's another one of the big differences between the V1 and V2 is that the V1 you kind of had is like here's some recommended possible buffer things. The V2 is like here's the buffer system. Maybe explain to folks why a buffer is necessary.
So for takes care of when it unloads the filament. You, it doesn't, you can't just push the filament back on the spool, but filamentalists came out and now we can. But the carrot tail, or excuse me, the cottontail buffer mounts to the ERCF. It's right there. It's close. It's compact. And so as filament comes out, it it expands in the buffer and it's just held there. Um, and it's close and low drag. That's one of the best about the carrot tail or the cottontail, excuse me, over the old ERCF. I think they call them carrot patch. Um, you don't have as long a bowden tube between the buffer and the
Mm.
drive gear, so there's a lot less. Um, there's other buffers out there. Some people they prefer other ones. There's the pica buffer, which is good. I have one of those printed. I've used it. It works well. Like I said, excuse me, the filamentalist came out, and it actually uses the filament itself, the rigidity of the filament itself, to drive the spool a little bit faster than the filament's coming in, so it winds back up nice and tight. And it's a pretty interesting system.
Whoa.
Um,
Okay, just pulled this up because this I had printed like 15 of the Girari spool rewinders, which use tension on the spool. And I never really got them to work perfectly because different spools have different amounts of friction. So you would need different, like plastic versus cardboard, you'd need different amounts of plasti dip and stuff. And I found that the mechanisms were a little too finicky. Sometimes the pins would break if the spool kind of exerted too much. So now this is really interesting. Now that I've printed all the cottontail, tell me 12 of them, by the way. Tell me about this a little bit more. So it actually, basically what it's doing, as I see, is it's using bearings to put the spool on such a low drag roller that just pushing the filament will cause it to roll and respool itself.
yeah. I, so I haven't printed one myself yet. I've been waiting on the one-way bearings. But the way I
Oh,
see it works is the filament is driven by a smaller wheel, or excuse me, the filament drives a smaller wheel that has a couple O-rings on it to drag to get on the filament, and those are geared to the spool rollers in such a way that as the filament is fed through, the smaller wheel drives the other bigger wheels to the spool so that the spool actually turns a little bit faster than the filament coming in. And
Wow.
in the GitHub, they talk about the O-rings will wear out over time because there's always a little bit of slip there. And but I've seen GSX 8299. He has them and he uses the heck out of them, and they look really slick. It's cool. Just when the filament comes out, the spool just backs up, and it's really neat.
That's really impressive. I mean, it's also amazing to me. Like, I can't keep track. I feel like every week there's just a new upgrade. And that was, I guess, part of my frustration as well with the version 1 is you're like, well, there's so many buffers, there's so many different add-ons. I like that the V2 has said, hey, this is kind of the main line. Get this going. This is the buffer you want. This is the filometrics you want. Get this going, and then go off into the world, which, by the way, is exactly the model of Voron, right? It's like whole open world. First, install the inductive probe, maybe clicky. Don't start messing around with tap until your printer's running, right? And I think that's the right way, rather than, okay, here's the ERCF. You're going to need a buffer. There's a lot of great ones out there, you know? So I think
That was a big drive for the V2 was to make everything cohesive, and we still work on that, trying to make everything fit together well, be well integrated.
Right. Now, there are a lot of kits out there. I am building one by Physek, which folks can check. I think we're going to have a link in the description if you want to support the channel. I know Cybor has one. Someone in the chat asked, when is LDO's kit going to be approved? Because I know a lot of people are LDO loyalists out there.
I think it's in the final stages. I really don't know. I provide feedback, and then Kinematic Digit and the other guys kind of, well, I think mostly Kinematic Digit is a go-between for the manufacturer. He's kind of our liaison engineer. Um, he talks back and forth with them, and I I would have to ask him where we're at with LDO, but I know I've reviewed one of their kits and we provided some feedback, and I think they're close.
Great.
And like anything else, LDO is fantastic quality, and everything I built from LDO is just spectacular.
Yeah, they're fantastic. I mean, they're also just great folks. You know, they support the community so much.
Yeah.
They actually were the first company to send me a printer and say, hey, we really see the potential of your channel, and you know, you need a bigger, faster, better printer. All I had was the Prusa and the CR10 back then, and they're like, just take this printer. You don't have to do anything. Just have it. So I have a real soft spot for them. I feel like I had so many other questions. By the way, Nuno Vicente says, now there's also the ERCF Jailbird buffer, similar to that buffer, but better basically, and encloses the filament. So that actually leads me to my next question, which is, there's a lot going on in the Voron Discord, and then there's a lot going on in the ERCF. There's 2 ERCF channels. Sometimes it can feel very overwhelming if you're not in it every single day, living and breathing. And let's face it, like, some people don't want, how do I put this correctly? For some people, this is a project. They don't want it to become like their new hobby, just tuning the ERCF and keeping up with the ERCF. It's a step, right? Like, you build a Voron, then you move on, or maybe you don't, right? Some people don't. So what's the best way for people to make sure that they understand kind of the latest, greatest modifications, but at the same time not have to read the entire Discord channel? Like, I almost wish, is there like a newsletter, or is there a YouTube channel that we don't know about where someone's reviewing and testing these modules? Or is it going to be the case where, like, I'm going to need to step up and be the one to make videos about the latest, greatest upgrades?
Well, there's not a newsletter. I think that's a good idea, though. Maybe something that, somebody could work on.
Yeah.
I haven't seen a lot around the, modifications for the ERCF. Uh, Atman's Workshop, I think it's called, did a build series, V2 ERCF, which is really good.
Atman's
Um,
Shop.
yeah, I believe that's what it's called. Uh,
All right, cool.
Starts with a K. Um,
Got it.
so yeah, it's pretty good. He does a lot of Voron stuff, and he recently went through a build on the ERCF V2. One
That
thing I would like to try. What's that?
that's what I was looking for. Thank you. Because when I look online, there's not a lot of content, and at some level, I was like, someone should just create a video simplifying all this ERCF stuff. And then I was like, oh, that someone's gonna have to be me, isn't it? But no, I'm really glad that someone else did it because, as my audience knows, like I'm really great at explaining things once I understand them, but I'm not an engineer. I'm not great at figuring it out by myself. Someone has to explain it to me, and then I'm really good at turning that into an engaging, fun to watch video. And I'm the first to admit it. Sorry, I cut you off though.
Oh, one thing I think I'd like to try. I'm not a videographer, and I think I've done 2 YouTube videos in my whole life, but there's a lot of questions on getting your ECR up and running in a configuration. We tried to do the wiki, make it logical and kind of a step through process, but I think a lot of people use video and it speaks to them better.
Yep.
And I think I'd like to try working through that. So I'm going to try recording a couple videos on let's just get this thing from, we've got an ECRF built here, sitting here on my
Yeah.
desk. What do I do
Oh,
next?
God, I would love that.
And
I I would
yeah,
happily volunteer many hours of my time helping you get the videos where you like them, like walk you through my process and some tricks of like B-roll and even scripting if you want, uh, just to have those videos, because I'll be honest with you, I don't want to. I want to know enough about the ERCF to have mine work and do a cursory, like, here's what's cool about the ERCF, here's what you can expect. I do not want to be the guy who does 10 videos about, I don't want to know that much about it to the point where I'd feel comfortable teaching people how to, but you already have that knowledge. So if I can give you my knowledge about the video stuff, you know, or if you really don't
that
want
would be
to
cool.
do the video, then you write the content and I'll script, you write it, I'll film it, we'll split the AdSense revenue. That's also an option.
Well, yeah, we could try and work something out. Like I said, I'm not a videographer. I imagine that's about like 3D printing. It's a journey, I'd imagine.
It is.
I
Fortunately,
yeah,
the beauty is I actually did a coaching call with someone today who was looking in starting a 3D printing business. And I found myself saying like 3 or 4 times, you got to remember, we're not at the stage of your cordless power drill or your video camera. Like we're where those products were 10 years after they became available on the market. So what I was going to say is the beauty with videography is personal video cameras have been out for 30 years now. Like I'm using a really good camera now, like things like focus, if you have the right camera, they're kind of dialed in for you, and
yeah,
all the information is so out there and so available on 3-point lighting and how to frame your shots and apertures, and that the gear is really good and the documentation is even better. Whereas with 3D printing, every week there's a new model. It's like, well, how do I adjust the Z offset
yeah,
on this new printer? Even I, as a full-time, 3D printing content creator, sometimes I'm like, I don't understand this. So
yeah.
yeah, but you have my personal phone number, so I'm super happy to help in any way that I can, because I really think if you look at the Voron itself and then you look at the ERCF, why has ERCF not seen the adoption that Voron has? Part of it is obviously the V2 is better than the V1 was, otherwise they wouldn't have released it. So it's now a better end product and it's more approachable. But like I said, I didn't want to flat out say this, but so much of the juicy knowledge is buried in people's heads or in Discord conversations from a year ago that are no longer relevant. And I've kind of found that if I really need the most up-to-date information, I have to ask again. Be like, hey, is this still the best buffer? And then, as Nuno commented, nope, like even, you and I need to be on top of this because there's a new buffer that came out a week ago. So yeah, having a channel just about, and I think to Nero's credit, he's done a good amount of content on the ERCF, but as his channel's grown, he's doing more general interest stuff too, not just Voron related content. So, hey man, you got a bunch of people in the chat here who are already ready to subscribe. Awesome.
Well,
so
I'll get to work then, I guess.
Awesome. Yeah, I'm happy to hop on a call with you and walk you through, like, I think if we spend an hour, I could have you churning out pretty good quality video. Remember, I've done video and videography and content creation for 11 years. So I've made all the mistakes. All the tip tuning that you've done, I've done shooting blurry video that's overexposed that no one wants to watch. So I want to ask, can you show us some of your multicolor prints and what's the last thing you printed? I'd love to end on a more personal part of your enjoyment of the hobby.
I've done some multicolor prints and they all get given away. My youngest son, who splits time between mom's house and mine, he gets the multicolored prints and takes them home to mom and order to school and then leaves them there. And lately a lot of it has been just really focused on the new kit reviews coming out, the beta stuff, printing a lot of new ports for what's coming up next on the ERCF. So my multicolor printing is lacking.
Wait, so hold on. Are you allowed to tell us what's coming next before I assemble this whole thing?
Well, I don't want to like go too far out and say something's coming that isn't. But what I can say is there is constant work on making the ERCF and more user friendly. One of the things that Kinematic Digit's working on right now is the coupler blocks in the buffer, so they work a little easier, more reliable
So
in the
it's not
switch activation.
new
that kind of thing.
features. It's more like tweaking and improving models of existing.
Yeah, a lot of that. And so Happy Hair has endless spool, which instead of using different colors, you can have two spools the same kind, and one runs out, it automatically switches to the other. Well, the amount of filament that's left in your Bowden tube has to be ejected, and it tends to get caught up in the buffer. It like trying to push a rope backwards, right?
Right.
So there's some work on how to use, say, a spare gate. We move and just use that to eject our filament out. And there's a lot of software work and a lot of hardware work as well. So I'd
Wait,
say look for something like that coming soon.
You can't just have the extruder pull through and the ERCF push it, even if the tips aren't lined up.
So one of the big problems is we have to catch everything, right? We have to have all scenarios. And this is an engineering question all the way through. What is the maximum that we're ever going to see happen? And one of the problems we have is you've got a gear drive at one end of the filament from the ECRCF that'll push it clear to the extruder gears, and then the extruder gears can drive. But what happens if you're, say, halfway between and we've run out of filament, we've got a half a Bowden full of filament, and now it's time to change colors. Well, the extruder gear can push it out, but there's no way to grab the other end and pull it the rest of the way.
I see. I was thinking of the endless filament scenario, but no, this isn't about that. Yeah, that's tricky. That's actually a really challenging problem.
Yep. And there's a lot of work going on how to handle it all. And there's some thought that, we could pre-scan the G code so that Happy Hair knows, how much is left in this tool change of filament, and is it worth it to push another one in behind it, or do we just need to pull it out before we run out? But
Oh,
that's all
interesting.
software stuff, and I'm not a great software guy.
And it's also predicated on knowing exactly how much filament is on the roll.
Yeah,
Which is never going to be
yeah.
reliable.
Well, yeah. In the
Huh.
in the cottontail buffer, there's pre-gate switches, and that's what triggers the run out. When one of those says, "Hey, there's no more filament here," we stop printing, back the filament out, and switch. If we have into the spool, we switch over. Otherwise, just pause. But once that gate triggers, Happy Hair has to know, how much more print, how much more is left to print in this tool change. Um, if it's more than the buffer, we'll go ahead and shove a filament behind it. If it's not, we're going to have to stop beforehand and pull it out and handle it that way. So there's a whole bunch of algorithmic decisions that need to be made. And I'm not 100% sure we can even get all the information to make that at this point. So
That's really cool. That is really, really cool. W. Level says, I was thinking about making an enraged rabbit carrot feeder, but I was a bit intimidated. They look super cool. Well, misery loves company, and I've printed out all the parts on mine, and I'm waiting. Any day now, I should have the actual kit from Fizek. Thank you, Fizek. And so I'm going to be building it probably maybe on a live stream. I don't know how many videos I'm going to do about it, but a live stream I definitely will do. So now's a good time to start because we can do it together. And also, now we have Ivan. I know where to email him. I have his personal email if I need help. My ulterior motive to the interview. Well, Ivan, I really appreciate your time. I learned a lot. I think our audience learned a lot. And I really look forward to your YouTube channel.
Well, I'm going to do my best. It's going to take a while, but I think I'll get there.
Awesome. Well, if I can help in any way, let me know. And if it's also, just, hey, you should make a YouTube short about this, explaining this new release so people know about it, I'm happy to do that as well.
Okay.
All right, my friend.
Well, thanks for having me.
My pleasure.
I really appreciate the time. And
I appreciate yours. You're the guest.
It was fun.
I appreciate your time.
Enjoyed it.
All right. Thanks, everyone, for tuning in. And check out the links in the description to Kiddoodle, our amazing kids 3D printer, and PCBWay, and Fizek, who makes an awesome ERCF kit. Take care. I'm going to take us out if I can find the button.
Thanks for tuning in to the Infill Podcast. For show notes or links to anything mentioned in today's episode, visit thenextlayer.com. If you enjoyed the episode, please don't forget to leave us a review wherever you're listening, or click the like button to let us know, and consider subscribing to The Next Layer on YouTube so you can tune in live and participate in the next conversation. We'll see you on The Next Layer.